All right. Diesel electric locomotive Aipd course, Chapter 2, Maintenance and Repair. Introduction: the four categories of maintenance: organizational, direct support, and general support, and depot. Original organizational maintenance is authorized for the performing and the responsibility of using organization on the equipment as it possesses. Direct support maintenance is authorized and performed by designated maintenance activities in direct support of the using organization. The category is limited to preparing end items and unserviceable assemblies in support of using organization on a return user basis. General support maintenance is authorized and performed in a designated table in the organization equipment. The toe on the table of distribution organization is the support of the Army supplied. Normally, the table of organization equipment and the table of distribution organization 3 organizations repair the overhaul material are required at the maintenance standards of the ready to issue conditions based on the applicable supported Army area supply requirements. Depot maintenance activities through the overhaul uneconomically repairable materials augmented by the procurement of program is satisfying overall. Any Army requirements when required to provide for the repair of the material beyond the capability of general support maintenance and organization appropriate for the technical manuals cover each of the category of the maintenance. For example, organization maintenance instructions diesel electric locomotive model MRS1 are given in TM 552210 20120. So since diesel engines range from about 59 to 2,590 horsepower, the service of the engine verifies the great deal of the engine marker services book instruction, but the pertinent technical manual should always be available to service personnel referred to before and repair work is attempted. Service schedules are usually worked out accordingly to the locomotive mileages and to the hours of an operation. The hours in service are probably for the best guide for such as the servicing, the tappet adjustment, and the changing of the oil filters and oil, while the mileage is good and guide for the spacing of the major overhauls. The time between the inspection depends on the quality of the fuel, lubrication, frequency of the cold starting engine, design features, atmospheric condition of the temperature, dust and humidity, and the load of the engine. Loads of less than 50% of the maximum engine output at extended periods will increase the engine maintenance. The chapter explains the checking, lubrication, other general maintenance, and commonly service parts of the locomotive following the part in the pattern of Chapter 1, maintenance of the mechanical parts discussed in Section 1, and maintenance of the electrical parts in Section 2. Troubleshooting is discussed in Section 3. Section 1, mechanical maintenance and repair. 2 general. Chapter 2, Section 2, general. Certain parts of the engine are repaired and others replaced because of the worn engine maker usually lists the expected life of each of the part, either the miles or hours of the operation. Components are subjected to continuous wear, including the cylinder liners, piston rings, valve, springs, guides, and bushings, injectors, timing gears, camshaft, rocker arms, camshaft, parts of the governor, parts of the fuel, lubricating water pumps, and regular checks should be made of the crankshaft, the most commonly part of the engine. Crankshaft distortion caused misalignment. The bearings should not exceed 2 to 3 thousandths of an inch. Auxiliary equipment such as traction motor, bolt, blower, belt, water pump, fuel pumps, and various control switches, relays, protective devices should be removed from the cleaning, calibration, adjustment, replacement, and completed reconditioned on units during the scheduled periodic inspection. Fuel, water, steam lines should be cleaned and periodically all valves inspected, repaired. The following paragraphs tell the procedures used in maintaining these and other parts of the locomotive. One of the usual manufacturer manuals, appropriate technical manuals provided with most of the complete instruction, the maintenance and repairs of the instruction given here in a minimal. 2.3 The piston and connection rod. The following procedure given by the subparagraph A and B: remove the inspection of the cast aluminum pistons, connection rods at 75,000 miles, forged aluminum ones at 85,000 miles. Repairs as necessary. Pistons, connection rods, assemblies, locomotives used in switching may require more than frequent repair. Pistons: before pulling the piston, remove any of the ridge on the liner with the reamer. The gaps of the rings that can be measured most accurately while holding them in place of the liner. After the piston is removed, clean the chips out of the crankcase. Clean the pistons, inspect them to defects, replace first and second compression rings, and examine the piston pin and bearing for the wear of the cracks and chips. B. Connection rods. Cleaning inspection connection rods, making certain the oil patches are often open, place an end defective rods. Examine the connection rod stud, bolts, and nuts, and if position seizures occur before the removal of the connection rod of the stud and bolt and nuts, remove the cotter pins and check the tightness of the nuts to determine if the bolts have been stretched. If they are stretched and they are not safe for further use. 2.4 The bearings. Never force the bearing of the bearing shells at the bearing face may be stretched at the shell distorted to note the identification mark on the shell that can be replaced correctly. Bearings should always be replaced in the same shells because of their location, and it can be determined how they are worn. To remove the bearing shells, take off the crankcase doors, opposite shells that remove the rotating of the engine and skirt position at opposite bank of the cylinders have completely entered into its liner. Unscrew the connection rod and nuts and bolts, taking out of the cap and its bearing. Tap at the cap from the rod, showing the bearing shells removed and disconnected so that the bearings can be removed. After the bearing is replaced, examine the grooves and oil holes to make sure that the passage is free obstruction. Also make the running testing before the releasing of the assembly for the service. Idle the engine a few minutes, then feel with the bearing shell if it is hot, smooth, the high spots of the bearings. Repeat the test with the switching. Locomotive the testing should be made consistent with the light switching duty for the first 8 hours, followed with an inspection of the bearings at the end of the test. Inspection maintenance procedure for the bearings generally can be illustrated through the bearings in the connection rod, crankshaft, axle, and journal. This shows the connection rod for the crankshaft. The connection rod bearings periodical inspection. Connection rod can be made without removing the piston connection rod assembly that has been done with blocking the bearing of the backing of the shaft away from the shell. When the connection rod assemblies are removed, inspect the face and the fillet of the crankshaft journal and the scored condition of the crankshaft journal to found with the score with the bearing area. Smooth off all irregularities by stoning of the fine grit stone. Do not stone lengthwise using a file. Clean to seal the crankshaft is not rounded, then clean all parts. Be sure to line up the oil holes when connecting the rod bearings to replace in place. They must have a clearance of the crankshaft journal. The clearance should be at least 1/10,000th of an inch crankshaft diameter, unless otherwise specified. The thrust must be parallel with respect to the crank cheek. Joining the period, they must move laterally with the crankshaft in any angular position. Connection rod should be tightened to the torque specified with the manufacturer or to the proper bolt elongation or stretch. The crankshaft bearings under the normal conditions. Crankshaft bearings receive lubrication by fourth lubrication system built into the engine proper. The bearing alignment is measured by the original engine frame and method of mounting. However, the misalignment may occur if one or more of the bearings permitted with wear unduly. The bearing becomes low and span will increase between the bearings supported with the shaft. That will introduce a heavy stress with the crank pins. If the condition is permitted to continue, it will result in the crankshaft bearing failure. Crankshaft bearings can be checked in several ways. One of the methods: locate the crank pin at the upper end, dead end center, force the shaft down to the firm seat of the bearing. After removing the valve of the levers, connect the air hose to the T indicator cock connection. Provide a pressure gauge as the cylinder head to the T-lock flywheel from the turning of the main air pressure in the cylinder 125 pounds more. Regulating valve located on the inlet side of the T. Measure distance between the gauge points of the crank cheeks of the micrometer of the strain gauge. There are locating crank pin lower dead center. Again, with the force of the shaft bearings, the measuring the distance between the gauge points for the two operational horizontal positions. Do not use an air pressure for the cylinder. In the cylinder when the bearings are in line, measure that will be the same. In most of the diesel, the top bearing shell is movable to the top of the cap. Lower the shell is rolled out and onto the position of the crankshaft. Unless bearings are opposite end of the engine, they should be removed on time. In the order, the crankshaft must be held in position. The shell should be rolled out into the position, same the direction rotational of the crankshaft. Crankshaft bearing failures are often caused by the shaft misalignment. Flexing condition of the turn may be traced and low misaligned bearings resulting from the low distorted bearing support or cracked engine frame. Bearing support should be tight in perfect alignment before shell is installed. When checking the wear of the bearing, measure the shell thickness of the micrometer at both sides at the bottom and at the position where showing the wear. If any of the number left of the complete set of the bearings is renewed, the shell must be scraped with a fine grit stone of within 10,000th of an inch, same thickness adjoining the bearings of the old shell. After the new shell is sized properly, should roll into place freely. When installing a complete set of the main bearings, roll the shell out from one of the end of the engine, install a new one, then replace the shell in the opposite end of the engine. In this manner, the crankshaft is kept in place of the intermediate bearings with the changing that are being changed. Less force necessary to rolling in the shells. With the shells in place, the cap tight, rotate the shaft by hand to make it sure that it's free. The engine is reassembled, idle it under its own load for a few minutes in order to locate any friction that has stopped the engine. Remove one shell at a time and scrape it necessary. Continue the operation until the shells show a good bearing. Axle bearings. Typical axle bearings maintenance involves checking the oil depth of 1 3/4 of an inch minimum or 3.5 maximum, measured on a slant. Changing any glaze of the packing, making sure that it is packed tightly against the windows and axles using suction pump to take the sample of the oil between the chamber and then checking it for water. The water is found with the withdrawal of the oil, repacking the bearings with the fresh packing. Bearings normally require repacking every 25 to 30,000 miles of service every 6 months, or whichever comes first. The two-pack axle bearings first emptied clean out of the packing chamber. The axle caps fitted with the spit and packing pusher. Inserted the web between the pusher and the axle to keep the spring compressed with the bearings is being packed. Saturated all the packing to be used with warm oil 24 hours, allowing to drain in 12 hours at the temperature of approximately 85 degrees so that the oil will not congeal. Fill the bearing with lubricating oil, then open the oil when the cover and the gauge of the depth of the oil in the bearing is not sufficiently full. Pour it only into the auxiliary oil well until the proper depth of the oil reached a 3.5-inch maximum measured on a slant. Journal bearings, all part of the journal box, interchangeable when new. All after the parts of the assembly operated together with a long time. Each part of the wear is a fit adjoining the parts. For example, if during the manufacture a slight irregularity were left on one of the part, the adjoining part would, after a while, wear and conform to a shape of irregularity. For this reason, the journal box and the bearing should be treated with the unit used only on the journal for which it belongs. The bearing, usually made on an alloy of tin and copper called the Babbitt metal. A journal barrel thrust bearing can be removed in the following manner: remove the waste of the journal boxes, but jack the box high enough that the locomotive weight is not resting on the journal bearing. Remove the spring cap, the gasket, lateral springs, and wedge at the top of the journal bearing. Hold the thrust bearing so that it will not fall off, and the springs are being removed. Insert the bowl into the whole front side of the bearing and pull out. If the waste is dirty, replace it and clean an oil-soaked waste pad. 2.5. The V-belts. Correct tension should be maintained with the V-belt. If the belt is too loose, it will slip and cause both sheave in the belt and the wear to the engine overheat. If it is too tight, the bearing is subjected to the overload and will wear rapidly. Belt tension may be checked depressing the belt in the center. The amount of deflection varies somewhat due to the variation of the drive center distance, but usually proper deflection will run from 1/2 to 1 inch. The pressure exerted at the center of the belt check with the deflection should be normal. The pressure to exert with one finger without straining. Whenever the set of belts is being applied, the center distance of the drive must be reduced so that the belts can be placed over the sheaths freely. If this were not done, it would necessarily force the belts to sheath grooves, causing ply breakage and cover damage, resulting in short service life of the belts. Checking pulley alignment after the belt tension is adjusted, since the movement of the equipment will cause undue wear on the new belts. After a set of V-belts has been applied, the drive should be run at least 15 minutes, allowing the belts to stretch, become well seated in the grooves, equalize on both sides of the drive, and they be checked in tension to the correctly matching. After the belts have been made primarily, run to check the belt deflection. It should be about 1 inch mid-span. Run to the drive at top speed, checking the driving pulley speed at the hand tachometer. The faults within 5% of the calculated speed. The belts are tight enough. However, the driving pulley speed cannot be brought up through the rating. Checking wear conditions of the sheaths, since sheaths with badly worn may not be delivered proper speeds. To find the speed of the driven pulley using the following formula: speed of the driving pulley, diameter driving pulley times the speed of revolutions per minute plus the diameter of the driving pulley. The same formula is used on flat belts as for V belts. 2.6. Aligning of the shafts. It is two or more rotating shafts are coupled with the proper alignment should be provided with the eliminated vibrating and bending of the shaft. The method of securing the satisfactory alignment will vary with the number of the bearings on each shaft, the type of the coupling. If the shaft and single bearings are aligned properly, there will be no radial displacement between the coupled ends, no angular displacement of the shaft. If each shaft is coupled that has more than one bearing, the type of the coupling must be used with the permanent small amount of the radial angular displacement, since it's not always been possible to achieve absolute alignment between the two shafts carried with the separate housing. Radial misalignment with the centers of the two shafts do not coincide with radial misalignment. Occurs the displacement illustrated with the figure 2.2 causes the excessive vibration wearing with the coupling because of the radial movement of the two halves of the coupling with respect to each of the other. The displacement also causes the pulsating loads on the bearings and shortening of their life. This shows radial displacement in the coupling, and this is an angular misalignment. The two shafts coming together with a slight angular misalignment illustrated in 2-3 presents, in addition to the setting of the vibration misalignment causing bending of the stress to set up in the shafts, resulting in additional bearing loads. The more the flexible the coupling, the less the load on the bearing and the less the stress will be set on the shaft. This shows the misalignment of the coupling. The trucks clean lubricated trucks are required to maintenance schedule lubrication orders when inspection trucks. Check the main casting, pedestal, liner, swing hangers for the damage of the wear, bolts and nuts, other fittings of the tightness, center plates, and the side bearings with excessive wear, springs for the weakness, cracks, and broken leads. In addition, with the test equalizer, the magnetic tester, the maintenance of the wheels equals maintenance of the wheels, axles. Journal box is a little more detailed, involving more than a routine checkup of the wear. Wheels and axles may have the turned or renewed. If the wheels are renewed, we'll remove them from the axle, then test them by the magnetic method. Rapid motor mounting axle bearings, caps, and inspect air axles, gears. Clean lubricating brake cylinders. Check the slack adjuster. Inspect the repair of the complete air brake. Jacking pads are provided with the body of locomotive to support the locomotive frame, raising the air from the truck. To remove the wax wheel and axle with removing the truck, using the drop table to give an axle. The axle gears can non-destructive inspection magnetic particle preferred each time the wheel is removed. The second pair of wheel axles is worn and torn. Condemning limits of axle and gears as free cracks. Defects of the gear is not in the condemning limits. New wheel may be applied with using the same axle gear with the axles not inspected with each of the which wheel removal. They recommended for the axles scrapped with the 2 pairs of the wheels have been worn to the condemning limits. Axle gears, if not subjected to non-destructive inspection, should not be used beyond the life of 2 axles. One pair of new wheels is mounted on the axle. Wheels must be carefully mated with the maximum variation of 1/16 of an inch of circumference, or 2 hundredths of an inch and 2/20,000ths of an inch, in diameter. New wheels are not available within the limits of variation. Old wheels meant to be used, and they should be matched closely as possible, turned and ground after the mounting. While the mounting pressure is referred to as following the tables as using the pressing wheels on an axle. While wheel mounting pressures in tons, minimum and maximum pressure limits are absolute, no tolerance limited. The 3 3/4 7-inch nominal wheel seat is 5/8 of an inch, minimum ton 30, maximum 55 on cast iron. Steels 50 and 70 on steel wheels. 4 1/4 by 8 of an inch, minimum wheel seat of diameter 5 3/4 of an inch. Cast iron 30 and 65 minimum maximum. Steel wheels 55 and 80. 5 by 9 is 6.5 nominal wheel setting with a 40 to 65 cast iron, 70 to 100 and steel. 5.5 to 10 7-inch wheel diameter. 45 to 70 cast iron, 75 to 110 steel. 6 by 11 7.5 of an inch by cast iron, 50 to 75 and 80 to 120 steel. 6.5 by 12-inch, 8 1/8 of an inch nominal wheel seating. There's no cast iron. Steel wheels are 85 to 130. Journal boxing. Before repacking the journal box, clean and examine if the cracks might leak out. Saturate the new packing in an oil temperature not less than 70 degrees Fahrenheit for at least 48 hours. When packing the sufficient drain, oil should not be dripped in from it, but should flow from it when it's squeezed. Stored packing must be kept in tight containers as well, so that they won't dry out. Air breakers. Before each trip, check the brakes to ensure that the air compressor provided with the air and enough of the expected surface pressure regulating devices that is working for the properly and brake valve that is working in the position. Water has been drained for the air brake valve and gauge is shown in figure 2.4. Wear damage of the brake rigging should be corrected immediately with the brake cylinder piston travel. This should be set in accordance with the standard operating procedures, adjusting with the usually necessary travel exceeding 2 inches from each of the piston when the levers, pins, and bushings have worn until the braking travel can be no longer between the turn up of the turnbuckle adjustment and the brake pull rod bank. Shorten moving the pin for the secondary hole in the rod when it becomes necessary to move the pin in the third hole. All parts should be replaced. Checking the following parts of piston non-pressure head assembly, piston lubricator and release spring, in strainer, cylinder, and valves. Piston and non-pressure head assembly. Clean the piston and non-pressure head assembly with the hydrocarbon cleaning fluid unless otherwise specified. If there are any cuts and deep scratches packing in the cup of the bearing surfaces, if worn so that it does not hold the property of the bearing of the surface of the cylinder wall, replace it when applying with the packing. The cups of the whole piston hold one of the side of the contact of the piston to allow the air to escape under the packing. The snapping of the cut up into place. This prevents the air pocket from forming between the packing and the piston head, which may cause the bad fit of the packing of the piston. Piston lubricated with the performance of replacing, reapplying, packing, cup cleaning with felt swab, piston lubricated with the brushing, re-lubricated with the soaking of the unit oil. If the swab does not have fuel contact with the cylinder, adjust the provided with the contact. This shows that the brake cylinder, piston, brake pipe, air gauge, main reserve, equalizing pressure gauge, automatic brake valve, bell ring, control valve, independent brake valve, and sander control. The release spring. The release spring shows that any of the dirt and the rust in the spot and the cleans to give it the coating of the approved rust preventive. If it is not cleaned or dirt, rust, or might be getting the cylinder wall strainer, the strainer can be removed from the inside of the non-pressure head with removing the snap ring, holding it into place by then removing the non-pressure head with the felt swab and be inspected with the replace if necessary. The brush of the whole hollow rod packing felt and the remove of the surface of the dirt and reconditioning with the soaking and soaking the strainer in the seat of oil and draining it. Cylinder completely coated with the hollow piston rod with a standard brake cylinder lubricant applied with the release spring and felt with lubricated non-pressure head using the same holding with the fixture dismantling, but before applying the reconditioned piston not pressure head to the cylinder. So clean the cylinder walls, lubricating them with good grade of braking cylinder lubricant and non-pressure head gasket in good condition. Do not to replace if and simply clean the gasket face. Valves. Clean and repair, lubricate the valvular parts of the equipment as regular intervals. Do not mishandle them while on the locomotive. Rather, remove them from take them to the shop equipped or proper for cleaning, repairing, and testing. Clean the dismantled valve, the valve assembly with the hydrocarbon clean and dry them with the air or clean cloth. Soak fuel felt lubricated parts in the standard triple valve oil. Drain them. Examine the oil, all rubber and wear for the cracking, flats, or beads or other damage. Repair the replace the metal parts of the necessary reassembling, lubricating the friction surfaces. Experts the rotator valves and sparingly with the standard triple valve oil. The lubricating rotating valve seats with the oil having the high surface tension characteristics prescribed in the appropriate reference to the rotary valve. Automatic brake valve can be lubricated between periodic cleanings without removing the entire cylinder and position. The CM vent is equipped with the self-lubricating piston. After cleaning the piston, removing the plug into the center, saturated the felt wheel with the standard triple valve oil. The plug is the oil parts of the independent brake valve self-lapping portion, which is led with the felt expander, should be removed with the regular intervals. Passages filled with the standard triple valve oil. 2.9. The sanders are checked before each of the trips to see if they operate properly and the jets of the vent in the port are not plugged. The sand control valve should be checked and cleaned annually as conditions require. Checks and springs are replaced if it leaks. So clean all parts in the small amount of the air brake of the oil on the cup washer, the O-ring, and the composition rubber valve before reassembling. 210. Fuel pump adjustment. The balance of the power of the cylinder can be checked by the measure of the maximum pressure and exhaust temperature of each of the cylinder. Low pressure and high temperature indicate the late timing. High pressure and high temperature indicate the injection is too much fuel. The amount of the fuel being injected is checked in the following way. Intake of the exhaust valve is enclosed with the Swanniking pipe is installed at the place of the pump. Delivers the pipe with the valve. Move the pump bracket bar to the full loaded position bar. The engine around the fuel stops. The following through the Swannick pipe. The pump is then ready to be tested and delivered. Each of the pump element is led off into the set of test nozzles when discharged with the measuring cylinders. In this way, the discharge for each of the pump can be measured under the working conditions. The fuel flow to the measure of the fuel flow number of the pump strokes must be known as the quantity of the fuel and desired position. Counter measures the number of the strokes in either the forward or reverse direction. Adjusting the screw indicates the position of the fuel rack. Adjusting the screw is mounted with the sleeve with the knotted to in such a manner that the fixed position is rack idle. Fuel off is managed with the proper relationship. Alpha one of the positions adjusted with the screw lock in the sleeve of the screw with the move until it's now in control sleeve unit. Other parts of the equipment are provided with the proper support. Filtering the return of the fuel oil filtered with the fuel delivered in the injection pump through the flexible hose. The relatively constant fuel pressure 35 to 40 psi is maintained with the pressure relief valve. Fuel bypass with the relief valve is returned to the fuel storage tank. Other checks after making sure that the injector nozzles are working properly. Check the fuel pump discharge valve with the spring assembly with load, speed, timing, water jacket, temperature remaining constant, compression cylinder pressure, exhausting temperatures normally remaining constant. Checking the fuel pump type of adjustment, and if it is not correct, adjusting the thickness of the shims to raise the lower position of the pump suction support for the individual pump. 211. The injection nozzle. If difficult, the injection nozzles can be the cause cylinder knock, overheating the engine, endure exhaust, and increase fuel consumption with the power loss of power. The tightness of all the nuts in the injector should be checked, since the leakage at this point may be preventing the injection to load the fuel to the drain in the crankcase. Lubricate the oil when the injector is replaced. Nuts should be slack until the air bubbles are out of the pipeline and pure of fuel is flowing. When testing nozzles, be sure to spray the directed away from the engine, because the oil must not be sprayed in the combustion chambers. Also, if it sprays and strikes in the hands or face, it will penetrate the skin, tightening the flowing of the parts. Check them from the fuel leakage, holding the nut, spraying guide, and holding nut and lock nut, fuel lead off stud, and the nuts holding the injection overhaul pipes and the holder. Some parts of the nozzles are shown in the cutaway sketch in the figure of 2.5. The fuel pumps are installed. They should not be sprung into the catch of the nut. If pipes do not line up with their connections, must be let and it's bent slightly. Clamp the pipes, preventing the vibration. If nozzle, the valve slim, smoky exhaust, engine pounding will occur. Locating the defective nozzle, cut out the cylinder in rotation. Open the pressure, and injection nozzles can be checked in testing devices using the spare pump to develop an injection pressure as follows. Attaching a spare pump to the injection tube on the test rack. Set up the fuel pump at the rack at the 20 millimeters travel test nozzle, pumping of the lever steadily until the fuel discharge. Note that the pressure indicates on the gauge the maximum pressure noted with the gauge. Each of the stroke of opening the pressure of the nozzle. Do not operate the lever quickly, as this will cause extremely high pressure to build up, giving an unreadable gauge reading. Turn the pressure adjusting screw on the top of the nozzle holder until the manufacturer's pressure specifications are met. After setting the pressure of the nozzle, set the fuel pump at the rack at the limit of its travel. Operate the test rig to see if the nozzle operates properly. 212. Lubricating system. The oil is changed with the filters replaced accordingly. Appropriate lubrication orders. Maintenance instruction. If it's necessary to flush the lubrication system, and it must be necessary to flush the lubricate the system. However, the replacing detergent only with another detergent brand detergent oil, or replacing the mineral oil with detergent oil that is necessary to drain the flush of the system with the metal particles of water. Or the oil when the engine is dirty, even after the detergent oil has been used. The flushing oil may either be the regular OE or used in either the crankcase, and if used in the temperatures of 150 to 250 degrees Fahrenheit, the OE 10 light grade oil. When using the light OE 10 grade, the oil engine should neither be pulling of the load of the idle above the speed of 425 RPMs. Lubrication intervals shown on lubrication orders are based on a normal operation, may be reduced and increased and compensated for the locomotive varying the normal. This shows the injection shield going down, or starting from up and going from the corners. Nozzle body of the nozzle cap, spindle, spring seat, lower holder body, adjusting spring seat, so upper retaining cap, nut, lock nut, adjusting screw gasket, leak off stud, and leak off nipple, nut, washer, inlet, nipple, inlet, stud, edge filter, bleeder, screw, and connection nipple. 213, the cooling system. Moving of the parts of the cooling system have to be oiled periodically. Frequently cleaning of the flushing of the system can be eliminated by using treated water, distilled water mixed with corrosion inhibitor. The untreated water causes the scale to form, and while system must be flushed, follows the flush with the clear water when it runs clear. The flush with the strong alkaline solution rinse will clear water. The flush will scale. Remove the rinse with the clear water to neutralize the weak alkaline solution. 214, the air system. Faulty operation of the air system is most often caused by warm parts or dirty dry worn filters. Piston and diaphragm of the part of it should be lubricated with the cleanest valves. Clean and oil air filter. Dry compressed air should be directed against the filter, or it can be cleaned by the alkali free hydrocarbon solvent, dried and dipped in oil bath and drained. Drain condensates the intercooler, keeping the intercooler core sections clean for the permanent the free passage of the cooling air, and checking the intercooling safety valve manually to be sure it is not struck if the intercooling pressure is usually high, and checking the operation of the high pressure suction discharge valve. If the pressure is usually unusually low, check the operation of low pressure suction discharge valve. Drain the intercooler every time the main reserves are drained, and drain the hock is located at the bottom header of each of the bank of the intercooler tubes. When the heading of the intercooler, be careful of avoiding the damage of the fine tubing, also keeping the placing of the undoing strainer of the headly assembled top of the header of the, if one place was the bottom of the header of the two piece of the accumulated expansion caused by the temporary change, the lower heads of the tie together with the bottom tie strap of the cap screws. When they are removed, intercooled with may be lifted vertically when the handling of the replacing of the strap to be kept distorting from the assembly. An orifice test should be shows whether the air compressor shown in the figure 2.6 could maintain the specified reserve pressure while air is escaping through an air orifice pressure. Validate various dimensions of the orifice. The speed compressor of the condemning limit is usually set approximately at 80% of the capacity of the new compressor. The compressor should be reconditioned if the air escapes for the orifice faster than it can be pumped. Repairs of the air compressor consist of principally through the cleaning of the installation, new piston rings, the renewing of the valve, the bearings of the air compressor crankshaft should be inspected, replaced necessary unless the bearing trouble experienced with the crankshaft will require little attention for long periods. Occasionally disassemble, overhaul the air compressor, remove the compressor coupling from the shaft to prevent damaging of the bearings. Before the disassembly, clean the compressor and mark the parts so that they are reassembled in the same position. Maintain the oil compressor crankcase as the parts of the levels are according to the maintenance schedules. Clean out the crankcase when the oil is changed, but do not use any of the flammable cleaning materials. If the oil pressure is high to low, check the oil relief valve and pump in the filters. This shows the an air compressor, SKO motor, air intake filters, underload valve, safety valve, and lube oil filler cap, crankshaft, crankcase, oil drain plug, oil leveler, and intercooler. Remove and inspect the cylinder liner and piston hone all the cylinder retained in service. After honing, to check the clearance of each of the piston cylinder and the piston rings removed. Also make the certain cylinder flange faces the perpendicular with the cylinder bore. Replace the crankshaft if it is bent and cracked, or if the bearing seats are worn excessively. Check the valves for the lifting of the wearing limit. Examine the bearings and the general condition of the proper end of the clearance, and disassemble the compressor governor and clean it in oil approximately once a year, and clean the replacing strainer and element. 215. Testing the repaired engines. Each repaired diesel engine should be operated and checked before it is released, and for service time, the fuel labor spent with braking on the engine will result in greater longevity efficiency of the unit. The check is made with the compression pressure of each of the cylinder, each or the gas temperature, each of the cylinder, various engine speeds, lubricating, oil pressure, temperatures, cooling, water temperature, supercharging, blower pressure, horsepower output, the varying conditions, the current, the voltage indicated by the main generator, characteristic curves, and individual throttle position, speed, loading, and the color, quality of exhaust gases, general sound, action of the engine under load with acceleration, action of the engine under the conditions simulating the engine under the load can be tested, sending the current from the main generator through the dynamometer. The measure of the generator's output, the liquid rheostat of the water box also enables the engine to operate at different speeds through that will be installed with the locomotive. Pulling the different loads water box is seldom used, however, because of the danger of electrocution. Other facilities for the testing of the engine include the cylinder pressure indicated with the maximum instantaneous pressure type of the curving drawing type of the pyrometer, thermocouples, voltmeter, ammeter with the shunts, pressure gauge with the thermometers, temperature indicators are part of the regular engine equipment. 216. The summary. With various maintenance services ordinarily performed during the routine maintenance inspection, clean lubrication is a part of the maintenance. Small and inexpensive parts may easier to replace. The repair of such replacements often ordered. The often other parts of the like such as fuses, some of the filters are necessarily replaced. Balancing and adjusting the parts of the common are also common. Removing the inspection of the cast aluminum bearings at 75,000 miles and forged aluminum ones at 85,000 miles. Removing the check bearings, being careful with avoiding the scratching of them and distorting them in shells. Cleaning, lubricating trucks, periodically turning, renewing, and replacing the wheels and axles. Periodically packing the journal box of the bearings, adjusting the brakes, replacing the brake parts, checking the fuel system, oil, moving the parts of the cooling system, replenishing it with treated water, and whatever the maintenance shop to be sure comply with the manufacturer's instructions and standard shop procedures. Section 2, electrical maintenance and repair.